Alright, so again we have our, once again, our angle side angle that says if you have two angles and a side not included between those two angles, congruent to two angles and the side not included in those two angles in another triangle. If you know that fact, then you automatically know that the two triangles are congruent to one another. That is the AAS postulate. Here we have an example. What is the most obvious way to prove that these two triangles are congruent? Well, again, our options for proving triangles congruent are SSS, SAS, ASA, and AAS. So let's look at the information we have. We have two angles and a side marked congruent to two angles and a side. So it couldn't be this one, which requires three sides. It couldn't be this one, which requires two sides. It would have to be one of these two. But we want to take a look and say, okay, where is that congruent side located? That's going to make the difference. If the side is between the two angles, it's ASA. If the side is not between the two angles, it's AAS. So here's an angle, here's an angle. Where is the side between those? Right here. And that is not our congruent side. Okay, so here we have an example of AAS. Two angles and a side not between the two angles, congruent to two angles, and the side not between those two angles in another triangle. That information allows us to say these triangles will be congruent by AAS.